What if I were to tell you that every star in the night sky was a cosmic life form with a birth, a life, and a death? While some stars quietly fade away, others explode so violently they could outshine entire galaxies. Every star starts out inside of a molecular cloud. These clouds can span hundreds of light years and contain the very ingredients needed for a new star to be born. Inside these clouds, gravity pulls particles together. Over millions of years, the gas becomes hotter and denser, forming a protostar. At this stage, it's just a big ball of hot hydrogen, but eventually it'll reach a temperature of 10 million degrees Celsius. Once the core becomes hot enough, a process called nuclear fusion starts. Hydrogen atoms begin smashing into each other, turning into helium atoms. This releases huge amounts of energy. The outward pressure created from fusion counteracts the inward pull of gravity. Once this balance is achieved, the star enters its main sequence phase. This is where the star will spend most of its life. Our sun is an example of this. Stars can stay like this for billions of years, but eventually their hydrogen fuel begins to run out. When the star has exhausted its supply of hydrogen, fusion slows down. This allows gravity to compress the core again, causing the outer layers of the star to expand dramatically. The star becomes a red giant. At this stage, it can grow hundreds of times larger than its original size. In the future, our sun will expand so much that it could swallow planets like Mercury and Venus. Now, what happens next is dependent on how massive the star is. For stars around the size of our sun, the ending is relatively calm. The star sheds its outer layers, creating what's known as a planetary nebula. What remains is called a white dwarf. These are incredibly dense and have the same mass as the sun, but in an area roughly the size of Earth. These cool down for billions of years before turning into black dwarfs. Unlike small stars, massive stars have very dramatic endings. These stars keep on fusing heavier and heavier elements until they produce iron. Unlike the other elements, iron doesn't produce any energy through fusion. Once that happens, the core collapses in the blink of an eye. Following that is one of the most powerful events in the universe, a supernova. A supernova can temporarily outshine an entire galaxy, and all while it's doing so, it's also scattering heavy elements across space, all of which become the building blocks for new stars, planets, and even life. After the supernova, the only remaining part of the star is the core. If the star isn't massive enough to fully collapse, it becomes a neutron star. This is an incredibly dense object with more mass than the sun packed into an area the size of a city. But if the core fully collapses, it'll turn into a black hole, an object with gravity so strong that once something crosses its event horizon, it won't be able to escape. Not even light can escape. So to summarize, the life cycle of a star looks like this: a molecular cloud, a protostar, a main sequence star, a red giant, and then a white dwarf, or a super red giant, a supernova, a neutron star, or black hole. And the coolest part about all of this is that the iron that we have inside of us was once a part of a star. So you could say that we're quite literally stardust. Thank y'all so much for watching. All the sources have been linked in the description. I've also taken multiple physics and math classes, so if you'd like more videos like this or have a certain topic that you'd like me to make a video over, just let me know in the comments. Please like and subscribe and enjoy the rest of your day.